HANSA.newscast. I'm Janne Silden, and today I'm joined by...
Hi, Volker Wenzel. You are here at Anschütz.
It's great to be here. We are at a special room.
This is our test area for bridge systems. So we have several bridges here, a large system here, and several more smaller ones for testing software, hardware. We could put this piece of navigation directly on a vessel and sail with it, or we have an interview here.
Yeah, perfect. Operationally, what makes jamming and spoofing difficult to handle, and how do they differ in impact?
So jamming and spoofing, we have to consider two things. So one side is we have to look on the sensor level, and one side on the system level. So from Anschütz perspective, we handle systems and sensors. We are a sensor maker and a system maker. And considering a sensor like a compass, jamming and spoofing situation might have an effect on a sensor or on the accuracy of a sensor. And on the system level, it really affects also the operational level. So the operator, for example, of course, would feel it, or the system needs to handle the situation and act accordingly.
Yeah. So that's also why is reliable heading still the backbone of navigation, even in highly digital bridge system? That's related?
That's pretty much related. So there are not so many sensors which are really giving data independent from the outside world. Oh. So there's only the gyro compass. The heading is completely independent of the surrounding, the echo sounder or echo and also the radar. But the heading is the baseline, because we need to know, as a navigator, we need to know where the vessel is heading to, yeah. Where is north, or where is my bow heading in which direction. From that on, we can navigate more or less, all the navigation builds up.
Yeah, okay. So what does consistency actually mean on the bridge, beyond putting all sensors on one system?
So consistency means to validate and check the sensors, or the values of the sensors between one and the other. And also not only, only the accuracy, it's also matters of update rate or trustworthiness, stuff like this. So considering, for example, GNSS signal, GPS signal, a position, it's not only about the place on Earth, it's also the range, the accuracy, where around this one point on Earth, and also about the timestamp, the age of this position. It's also about validation with other kind of information, other kind of GNSS signal, or other kind of satellite systems. So consistency means to have the full picture for all sensors together in one place.
How do you do that? If we are now in a room with where we see all the screens and everything. So I was just wondering, there's a lot going on in the background with this technology.
It's beneath the console. So we have a bridge behind us with all the PCs, and in our system we let's call it backbone. On the backbone there's a CCRS, a consistent common reference system running, which checks the validity and the consistency of each sensor with some algorithms, meaning they check the one sensor itself or with other sensors. For example, for the GPS or GNSS, we check for update rate. We check for the probability of the position. So can this position really be on that place, or like if you have a position jump, a vessel cannot run like 100 knots. It's impossible. So you cannot move from the last position some seconds ago to the next one in two long steps. Such, let's say, validation circles are running on the back, and therefore you can see the consistency and the validity of a sensor. And then if the system would detect such a jump, for example, a position jump, it would rate this GPS 1, for example, as less trustworthy, and will give a warning, or will automatically choose another more trustworthy sensor.
Okay. But why are traditional navigation methods still essential, even with modern radar and how do you say? Estes overlays.
So again, considering this situation with the GNSS signal, a failed GNSS signal, a jump is easy to detect from algorithm perspective. Yeah. But in a really malicious scenario where, for example, in a military environment, or in an area where military actors are failing this position signal, the way would be to smoothly, easily change the position. So the system would not give a warning because of the small changes. Okay. And in that case, of course, you need somebody who's watching the systems. This is still a human, and they need to be able to still work in the traditional ways of doing navigation. And on the other hand, if it complete fails, like in a scenario with a simple disturbance of such signals, which is also quite often the case, honestly. So there are areas like in Suez Canal, for example, north of Suez Canal, there is just no GPS signal from time to time because it's jammed. Then, of course, the navigators still need to put in a position, or to put in a failed sensor, and the easiest way is to give him the same tools as in the former times, which are long known and well established. Yeah. So like bearings and position by distance and stuff like this. Yeah,
I learned you know how to do exactly that yourself.
Yes, I have I'm a master mariner. I have not a valid license, but 10 years ago I worked on vessels. Yes, absolutely. Yeah.
Yeah. If you strip everything down, what are the non-negotiable design principles of a reliable navigation architecture?
That's of course a tricky and a wide question, but it all comes about safety. So we need a reliable, safe system which provides the best and easy use for the operator. Meaning, in the end, it needs to provide a safe navigation.
Do you have a favorite sensor or component or part of the bridge?
A favorite?
It does exist something like that.
I like our steering system really much. It's maybe because it's maybe the most touched tool by somebody who's working on a bridge.
Yeah. Thanks a lot, Volker, for explaining everything and your insights, and also your own favorite part of it.
Thank you for your visit, and thank you for being in your podcast.